રિવાઇવ થઈ ગયો પછી ખબર પડે ઓફ છે કેમેરા. Okay, so some subset to Microsoft now. To see a small object. M times mu. So here is a typical question. Mostly only 3 formula માંથી જ કરવાનું. Okay, there's not much to worry about. So there is a small object and we want to see it 10 times bigger. See, we want to see it 10 times bigger. આનો મતલબ આવો ન થાય. I hope you understand that this is wrong. I'll tell you why. HI by H only tells you what is the size of image and size of object. But what if image is very far? Suppose एक object only, any image बनाए आटली मोटी, but that image is very far, तो ये नानी दिखाई नहीं. Make sense? So the key thing is to see it 10 times bigger. So to see it 10 times bigger, we don't have m equal to 10. If you remember, I did explain that m is not same as mp. Right? So this first line actually means that mp is equal to 10. Did you understand? Yes, no. First thing. Clear? mp is equal to 10. Because we want to see it 10 times bigger. Question may not give image is 10 times bigger than object. The two are different. Got it? Okay. How is it start? mp is 10 times bigger. What do we have to find? Okay. Focal length of that magnifying glass, which is a simple matter. Right? अच्छा तो कई फॉर्मूला यूज करता हूँ d by f or 1 plus d by f or d by u. Well, the other clue lies here. Without straining the eye would mean normal adjustment. Right? You see, human eye can see to infinity without any kind of problem at all. Really normal. Okay, so wherever you see this kind of thing, you understand that this image is going to be made at infinity. समझाए थे? Image at infinity. You can try what I'm saying. તમારે દૂર જવો છે ને તો આ એકદમ રિલેક્સ થઈ જશે. And when you try to see close, you will realize that you have to change something. Try કરી જોજો. You will be able to notice that. Right? The closer you get, you'll have to change something. Right? So, whenever it says without straining the eye, that would actually mean normal thing. That is image at infinity. Clear? You get what I'm saying? So, હવે આ કેસમાં શું કરવાનું? Which formula? Image at infinity વાળા કેસમાં mp is equal to d by f. Got it? So just use mp is d by f and you get your answer. What will it be? 2.5. Understood? Okay. I some basic thing started. Let's go to another one. like this way. Did you understand the question, everyone? Right? Again, I'd just like to remind everyone that magnifying power and magnification, they are not same. If they are same, that's a coincidence, right? એવું થાય કોઈ વાર, but it's not a rule. So while you finish solving that question, I'll draw the diagram for a comfort microscope. Are you able to see, or do I need to draw it larger? Who says larger? Raise your hand. Are you able to see things? Done? Did you solve that question? What answer do you get? માસ્ક માં બોલવું નથી ભાવતું એવું છે. તો આવે પૂરો 6 સેન્ટીમીટર. 6 સેન્ટીમીટર. મેગ્નિફિકેશન આન્સર સેન્ટીમીટર માં minus, it won't be negative because we always get virtual image. 6, let's check. So it is given that we have to get maximum magnifying power. To get maximum magnifying power, where should you put the object? Where do we get image? At the near point, that is at 25 centimeter, but because of sign convention we must use negative. Okay, right? So v is minus 25. We don't know what is u. Now we want to find magnification. Focal length ખબર છે, જો આટલું જ ખબર હોય અને ઓલી m ની ફોર્મ્યુલા ખબર છે v અને f વાળી, આવા કેસીસમાં જો એનાથી સ્પીડ કેટલી વધી જાય તમારી. ઓલું બધું ફાઇન્ડ કઈ નહીં કરવાનું, સીધી ફોર્મ્યુલા. Do you remember anyone? I asked you to make 3 formula of m. Who remember that f v formula? Very good, Harshad. Can you please say it? મને નથી યાદ, હું તને બહુ honestly પૂછું છું. Sorry? f minus v by f. F minus v by f. You are absolutely sure? Okay. 99. Never mind. That's good enough. So if you put values, we'll get the answer, right? So 5 minus minus 25. Convex length હોય ને એટલે plus 5. 5. So this is going to give you 30 by 5. That is 6. Clear? What would be the routine way to find u? By using length formula, correct? Once you find u, then you can put it into v by u. Alright? But you can see how this makes it easy, if you can remember that. Okay, only ત્રણે યાદ રાખો, for length and for mirror also. Does help. Try કરો અને યાદ રહે તો easy થઈ જાય. Well then, let's come to this compound microscope. Now, a compound microscope is actually made to solve some of the problems of a simple microscope. Like I told you that you have a limit to the maximum magnifying power, this one. What is maximum magnifying power possible? 1 plus d by f. It can't be more than that. So what if you want more magnifying power? Right? Sometimes if you're trying to see a very small object, what do? Well, we use compound microscope. So here what happens is that these two lenses, which are called objective and eyepiece. Okay, so these two lenses, which are called objective and eyepiece, they magnify it step by step. So this one will magnify, and then this image is then further magnified and giving a final image here. Okay, right? So two-step process. Now to do this, what happens is, listen to this carefully. Objective lens, which is facing the object, this is object. So this objective lens, first of all, gives a real and inverted image. Right? So we have to put this object beyond the focus. You think of those cases of convex lens. To get a real and inverted and enlarged image, you should put the object away from the focus, right? That is between F and C. And the scene, okay, between focal length and double of focus. Correct? Okay? So that's where you put it. Correct? Then you get this image. Now this image becomes object for eyepiece. Then we get a final virtual image here. So this eyepiece behaves just like simple microscope. Make no mistake about it. It just behaves like a simple microscope. But for this eyepiece, this is the object. It already magnified, say, partially magnified. Two-step process. Got it? Okay. Now let's think of all this here. So let's say this is the object here, right? With some height HO. We don't care about that. Let's say it's making an angle, some angle over here, theta. So if I take those triangles out and I'll draw it again. If I take those triangles out and I'll draw it again, right? So what I'm getting is, here and here we're getting angle theta, right? No, nothing on that. Excuse me. But not those triangles. We should take these two triangles. Here and right. So I take that out once again. This is FO, focal length of, focus of object. Clear? What's this? HI. Agreed? HO. Excuse me. HO. Similarly over here, this is HI. Right? Clear? This angle theta, this angle also theta. They are going to be same. Okay. Now this distance is focal length of what object? Clear? What about this distance from FO to this B dash? Okay. Now that's where I'm going to explain how we use a compound microscope. Right? I'm erasing this and I'll write whatever steps need to be written. So we are deriving this formula, first of all. In general, magnifying power because of a compound microscope is M is equal to. Do you remember? We can think of it like this: magnification by 1 into magnification by second. Similarly, what we are considering is, listen to this carefully. What we are considering is that first lens is going to magnify it by how much amount, by what quantity. It will do it by Hi by Ho. Correct? But that Hi by Ho, you can also obviously write it as, suppose this is the distance between this image and this objective. So VO. And here UO, did these symbols make sense to you? VO means image distance for object. UO means object distance for object. So Hi by Ho is VO by UO. Make sense? And I agree this is magnifying power, there is no doubt about it. But what is happening is that this is a two-stage process. In the first one, it will magnify, that is lateral magnification. અને પછી એંગ્યુલર મેગ્નિફિકેશન. ઓકે, તો પહેલા એની ઇમેજ આવી વધારી ને પછી એંગલ મોટો થાય. ઓકે, so it's like that, two step process. Now over here we have to do it for the eyepiece, right? M2 is for the eyepiece. Now again for the eyepiece, if you consider that it's a simple magnitude, then it's going to make it that many times larger. It's going to make it appear that many times larger. Did you understand this step? We're using the magnifying power of a simple microscope. D by A. So that is M1 into M. This is the general formula. This works every time. But this is very clumsy to use. I'll tell you why. एक आज खबर होय પછી આ ફાઇન્ડ કરવાનું પછી આ બધું. But we have been considered a special formula which is for normal setting. Okay, or normal adjustment. That is once again, where is the final image? For normal adjustment, where should be the final image? At infinity. Barabar? So that final image, this image has to be at infinity. I image kone bane? Which length made this image? Eyepiece. Now to get the final image at infinity from the eyepiece, where should this be? Where should this object be? A object ache na amare. Where should this object be? At the focus. Very good. So do you agree that when we do this kind of diagram for normal setting, B dash and F E become the same point? Yes or no? કેમ આ ક્યાં આવી જશે? Focus. Clear? So B dash and FE become the same point. Make sense? So here if I write B dash is equal to FE or normal adjustment, what's this distance? Can you say that this distance is the distance between the two focus? One of objective, one of eyepiece. If I want to define, look at this. We are talking about distance between FO point and FE point. Right? Okay, we are talking about distance between FO point and FE point. So we are going to define it properly. Okay, right? So for normal setting, A dash B dash should be at FE. Right? For normal setting, A dash B dash should be at FE. Right? Okay, so you could write, we define tube length. Okay, a new term, tube length. So what is tube length? Symbol is F, and that is equal to the distance between focus of objective and focus of eyepiece. Distance. What's that called? Tube length. You'll have to remember that term. Okay, question mark tube length. I repeat, distance between this FO and this FE here. That's called tube length of the microscope. Okay, so if we consider it that, here I can easily write this as L. Find distance between FO and FE becomes L. Okay, now let's repeat. So for this case, that is for once again for normal setting or normal adjustment, we have M is equal to, હવે હું VO by UO નહીં, મારે એનું કામ નથી. I am going to write HI by HO. Why? Because you can clearly see from here that HI by HO is nothing but L upon FO. Did you understand? Look at this diagram. HI by HO is tan theta opposite upon adjacent sizes, or by similarity also, whichever you like. Okay, so tan theta HI by L is equal to tan theta HO by FO. Based on that, we get HI by HO is equal to L by F. Alright? Okay. But this is only M1. So the M1 is value type because we are taking this image, this object. Into M2. So it's a simple. So finally, we get the net magnifying power of a simple compound microscope as LD by FO. Right? Okay, but be warned, આના માટે જ યુઝ કરવાનો. સપોઝ તમને નો ખબર હોય તો whether it is normal adjustment or not, then you have to fall back to this. Right? This is the basic formula. This will work every time. But it takes more effort to use this because you have to find this. U and V. Okay? Alright. Shall I erase it? Do it. I'm erasing this one. Draw a diagram, things will be very clear. There you go, Purvedra. Done. Okay. If you just draw a rough diagram, okay, but the size this is FO. Somewhere here is F, right? What values are given? Distance between these two is 7 centimeters. What's the focal length of objective? 1 centimeter. What's the focal length of eyepiece? 5 centimeters. What's the distance between these two? 1. Clear? બસ આવું જ કરવાનું છે અને હવે ફોર્મ્યુલા LD by FO FE. Okay, so L is 1, D is 25. D તો યાદ રાખવાનું છે. FO and FE, put the values 5 and 1. So this makes a very poor compound microscope. Okay, 5 તો simple microscope માં આવી જાય. Generally compound microscopes have higher magnification like 100. Okay. Understood how to approach these kind of questions. આમાં બહુ બધા variations possible છે, but generally they don't go, they don't ask very tough ones. Sometimes what they do is they give you that here is some object અને પછી આમાંથી એક બે details નો આપે. Now you are supposed to do everything. તો એ થઈ જાય કે object distance આપ્યો હોય અને કીધું હોય normal adjustment. So first of all you can find image distance. Wherever that image is formed, that's where FE must be. Do you agree?
Yes.
બરાબર. તો એ મળી જાય, આ ડિસ્ટન્સ આપ્યું છે તમને, આ મળી ગયું. So you will be able to find FE, correct?
Yes.
FE મળી ગયું પછી તમે હજી આગળ કરી શકો. You can find L now and then do LD by FF. Understood how it can be changed, right? બધું સેમ જ રહે, ખાલી એક ડેટા બદલી નાખે તો તમારી મેથડ બદલી. Okay, right. So that's about compound microscope. Now there's just one thing that I want to tell you. There are lots of rumors going on around everywhere about syllabus. I want to make it very clear. તમારે વાંચો તો બ્રોશર વાંચી લે, તો મેં તો 5 વાર વાંચી લીધું, because things are very confusing. It is just that they are going to give you 30 questions, 20 MCQs with negative markings as usual, and 10 other ones. Right? Out of those 10 you have to attempt any 5. You can attempt only 5. પાંચે પાંચ ખોટા પડે તોય 5. Okay, you can attempt only 5. It's not like you can attempt all 10 પછી જોઈ જશે. Okay, the moment you attempt 5, that section will freeze. તમને ઈ છઠ્ઠો વાંચવા જ નહીં દે. Clear? First of all, the second thing, there is no reduction in syllabus. First, this is something that should be clear to everyone. Instead of that, they are giving 5 extra questions with the hope that those who have not studied some section here and there in the textbook, they'll be able to do it. They'll be able to leave that and still be able to attempt 25. હવે હું તમને પ્રોબ્લેમ સમજાવું. આ તો નાના છોકરાઓને ઉલ્લુ બનાવે છે. That doesn't mean that out of whatever we are going to cover, only 5 questions are going to be asked. At first look, it seems એવું હોવું જોઈએ, પણ એવું નહીં હોય. Why? Because every board has different syllabus reduction. Correct? તમારું જે થયું એ CBSE જેવું છે, પણ બધાનું સેમ નહીં હોય. મહારાષ્ટ્રવાળાનું અલગ હશે, રાજસ્થાનવાળાનું અલગ હશે. Got it? એ લોકો નક્કી કેવી રીતે કરશે કે કયા 5 ઓલામાં નાખવા? કે તમને બધાને અલગ પેપર આપશે? તો હજારો કેસ થઈ જાય સુપ્રીમ કોર્ટમાં. ઓકે, સમજાય છે? So what they are going to do is they are going to give 30 questions from the whole syllabus. હવે તમારા નસીબ. સમજી ગયા? There are absolutely no options. એટલે ખરેખર આ તો ઓપ્શન જેવું છે જ નહીં. Because you think about it, there are more than 13 or 14 boards in the whole country. વધુ હશે, એનાથી 20 જેવા છે લગભગ હવે તો. So it's a very tough task to balance those 5 questions. સમજ પડે? એકનું કાઢે તો એમાં બીજાનું આવી જાય. You get it? અને કંઈ ઇન્ડિવિજ્યુઅલ પેપર તો હોય નહીં કે ચલો ગુજરાત બોર્ડના સ્ટુડન્ટ માટે 5 આ ક્વેશ્ચન, બીજા માટે આ 5, એવું હોય. Okay, and suppose you attempt only 10 MCQs, do you get to attempt 10 subjective? No, એવું નથી. એવા એમમાં ન રહેતા. It's not that from 30 you can attempt any 25. No. From 20 MCQs you have to attempt 20, or you can attempt 20. And from remaining 10 you can attempt 5 only. So practically if you see it, there are no options. સમજ પડે છે? There are no options. કારણ કે સપોઝ કમ્પાઉન્ડ માઇક્રોસ્કોપ નો ક્વેશ્ચન 20 MCQs માં આવે, શું કરશો? છોડી દેશો? એના બદલે ઓલો 6 તો કંઈ કરવા નથી મળતો. You get what I am saying? And it's not written anywhere that this will be asked in these 5 only. સમજી લો બરાબર. અને મેં તમને કીધું એવું પોસિબલ નથી, કારણ કે આપણે કાઢ્યું છે. સપોઝ મહારાષ્ટ્રમાં ન કાઢ્યું હોય તો then it's an advantage to them. Do you agree? ખરી ખબર? તો એટલે આ બધો બહુ પ્રોબ્લેમ છે. સો ડુ નોટ એક્સપેક્ટ ઓર ડુ નોટ રિલાય ઓન ધીઝ ઓપ્શન્સ. એના બદલે ખાલી એટલું સમજી લો કે 10 ક્વેશ્ચન્સમાંથી 5 આપણને ઈઝી જે લાગે આપણે કરવા. Got it? That's the only thing that is easier for you this year. Right? ચલો, ટેલિસ્કોપ. એટલે આ બધા ટોપિક્સ કરવા જરૂરી જ છે. કે I spent the whole evening yesterday trying to figure out what to do about this. કારણ કે બેલેન્સ કરવું પડે ને, નવા ટોપિક શીખવાડું કે પ્રેક્ટિસ કરાવું? ઓબ્વિયસ ક્વેશ્ચન. સપોઝ ઓલામાં 5 જ પૂછવાના હોય તો પછી આનો જ કરાવે, આ ફેંકી દેવાય. અગ્રીડ? સપોઝ આપણને ખબર છે કે 5 ક્વેશ્ચન જ પૂછશે આ બધામાંથી, આટલું કેવડું મોટું લિસ્ટ છે મારી આગળ. રાઈટ? તો એમાંથી 5 જ કરવાનું હોય તો આપણે કરીએ જ નહીં. We will focus on other 25, but it's not that clear. So we'll have to do everything. At least જે hot topics છે એ તો કરવા જ પડે. Right? Because there are offered. Okay. Telescope. Very easy to consider after compound microscope. So a telescope is something that has a big objective and small eyepiece. ઓલાથી ઊંધો ટાઈપ. ઓલામાં સ્મોલ આઈપીસ બિગ ઓબ્જેક્ટ. ઓકે, એવું કંઈ પૂછે નહીં, આ તો ખાલી ડ્રો કરતી વખતે એવું થઈ જ જાય. ઓકે, and here in telescope once again we have magnifying power. The definition is same, angle upon angle. Clear? The definition is same, angle upon angle, right? But what happens is, if you compare two situations, like one where you are seeing it using a telescope, right? So finally, let's say generally telescope is used to observe something that's very far, right? So let's say this is principal axis, or this is the direction in which you are looking, and અહીંયા કોઈ object આટલું દેખાય છે. Okay, but why am I not drawing it? ક્યાં draw કરવા જો? Star હોય તો? Understood what I'm saying? So just rays, that's it. Clear? Now what happens is, this ray suppose passes through optical axis and then it, refracts over here and you see it. That's it. Right? So finally, what happens is that you're going to get some virtual enlarged direct image. That part is same as my compound microscope. Once again, eyepiece behaves same as what? Simple microscope. એના જેવું સારું એક કંઈ નથી. Okay? Because when object is at infinity, listen to this carefully. Object at infinity. So first image આના focus પર આવે. Correct? I am not drawing the ray. બીજો ray કેવી રીતે draw કરી શકાય? અહીંથી ક્યાંક આમથી draw કરો અને પછી આમ જતો હોય, એવી રીતે something like that. Okay? But we don't need to worry about all the rays. Let's say that first image is from here. અહીંયા આપણે કહીએ a dash b dash. સમજુતી b dash a dash. Good so far? જેવું માઇક્રોસ્કોપમાં તો છે. Right? Now suppose this angle is alpha. Right? So અહીંયા alpha આવે. Do you agree with me? Vertically opposite. On the other hand, if you consider that final image is formed here, and when you see it, it makes an angle beta at your eye. Right? Ultimately, if you use a microscope, if you use a telescope, you are getting an angle beta. Okay, but if you see it with naked eye, again, try to recall. This is to be measured with naked eye. Yeah, and this is with an instrument. એટલે microscope હોય કે telescope. So theta upon theta. This is with naked eye. So if you are going to see it with the naked eye, so આ length ની જગ્યાએ તમારી eye હોય. Correct? સૌથી પહેલા લાઈટ ક્યાં પડશે? If you are seeing it with naked eye, on your eye. બીજું તો કઈ છે નહીં. So if you see the same object with naked eye, it's going to make an angle alpha. સમજ પડે છે? But if you watch it with telescope, when you see it, it makes an angle beta. Got the difference? With the telescope, you see it makes beta. Without the telescope, then directly you are going to see it. So light એમ જ આવશે. જેમ આમાં આવે છે એવી રીતે. Instead of this lens, you have your eye. Very covered. So that's why this is beta. હવે આ beta and alpha find out. Okay, we just have to find out beta and alpha. Right? So obviously a proper diagram needs to be drawn. I mean, the વધારે પડતું draw કર્યું છે, I have to say. કંઈ ખોટું નથી, but we need to do it properly. કારણ કે geometry કરવાનું ને, બરાબર? So you see what happens here, that if you think of lots of rays, can you think of one ray like this which will go through this? કારણ કે અહીંયા ray બધા meet થશે. Correct? Where is the image formed? Where two or more rays will meet. Right? So all the rays coming from this object, they will meet here. એટલે ત્યાં a dash. So if you think of the rays going from here, you can also think of some ray going like this to your eye. Okay, that when extended back gives you this. Probably I need to draw it very large. Okay, so it should go here. ચીટિંગ કરતા હતા ને ડ્રો કરવામાં એક મિનિટ પહેલા આટલું ડ્રો કરી નાખવાનું અને આ પછી ડ્રો કરો. ઓકે, ડન. નાનું કરી નાખ્યું ટેલિસ્કોપ. right? So what happens now? The rays go from here, go from here. What do you get over diagram now? Here is the first image, and then we get its virtual image. So to get virtual image, once again this should be within focus. याद आयो? Same as compound microscope. आटलो part same જ છે, right? So where is angle beta? Once again, this is where beta is. So I'm inverted બે triangles બને. If you look at it carefully, અહીંયા ઓલી image છે, અહીંયા alpha છે, અહીંયા beta. Do you see that?
Yes.
Now, over here, if this object is very far, then the first image is formed at focal length of objective. Do you agree? Object very far. So image क्या बनसे? At focus, right? So this is f. Okay. Then on that side, again, if you want to see the virtual image, so focus of eyepiece should be slightly on the left side. જેવું compound microscope ના diagram માં. But if you look for normal adjustment, then once again this Fe and B dash have to be at the same point. Exactly the same concept as it was earlier. Very cover. Fe and B dash are at the same point. Now, if Fe and B dash are at the same point, so our distance Fe થઈ જાય. Correct? આ focal length થઈ ગઈ. કોની focal length? Eyepiece. Okay, so this height is common and suppose આપણે h height લઈએ. So easily you can derive a relation that tan beta upon tan alpha is equal to hi by fe divided by hi by fo. Clear? What is cover? Tan beta tan alpha. That is nothing but fo by f. But typically, once again, we are talking about small angles. So, if we take small angle, beta by alpha will become fo by f. So, આમાં એક જ formula છે. બરાબર? Of course, you could have the other one. And the general case કેવો આવે? General case માં તમને આ એકેય ન ખબર. So here you would have to write BO, here you would have to write UE. समझा? क्या ना समझा? Image distance for object. પછી ઓલી બાજુ શું આવે? Object distance for eyepiece. This is the most general case. અને પછી એમાં tan beta upon tan alpha કરો એટલે આવે. પણ એવું લગભગ પૂછતા નથી. Okay? Right? So this is normally good enough for you. Again, don't forget this is only valid for normal adjustment. આપણે બધી ફોર્મ્યુલા એના માટે ડિરાઈવ કરી. Right? And here there is one more term which can probably confuse you. Right? અહીંયા લખી દઉં. That is called length of telescope. It's called length of telescope. Only નહીં tube length નહીં. Okay, it's called length of telescope. And that length of telescope is simply સૌથી easy વસ્તુ distance between lenses. સમજી ગયા? Simply the distance between lenses. એટલે આ બે વચ્ચે જે distance છે. That's called length of telescope. Now, in normal adjustment, you have L is equal to FO plus FE. આ સમજાણું? આ length L લખું છું. I know it's confusing, but we don't have another symbol. સમજાણું કે ન સમજાણું? Think about it. What do we have in normal adjustment case? અહીંયા FO આવે, અહીંયા FE આવે. બરાબર? This is the first length objective. અહીંયા eyepiece છે. આ બે વચ્ચે કેટલું distance છે? FO plus FE. Got it? Okay? So that's what we have. Right? બધું આ યાદ રાખજો. કોકવાર ઇનડાયરેક્ટલી આવી રીતે આપી દીધું હોય પછી આપણે for example they might say length of the telescope is let's say 10 centimeter and focal length of eyepiece is 10 mm. Length of telescope is let's say 10 centimeter, focal length of eyepiece is 10 mm. Then find magnifying power of telescope. ખાલી એટલું જ પૂછો. Understood? So just use this to find FO. બરાબર? તો શું આવી જશે? 9/1 આવશે ને? Clear or not clear? Okay? So that's it. And a ખાલી conceptual theoretical base is okay. Why is the objective large? To collect more light. Okay, to collect more light. આપણી આંખ નાની it can see very few things. If it's large, then it could collect more light. સમજાય છે? So you can see faint objects. And one more thing, resolution યાદ છે? કાલે કર્યું હતું ને? તો નહોતું કર્યું, કાલ કર્યું. Yeah. Resolving power. Do you remember that resolving power of an instrument like this is this 1.2 to lambda by a no reciprocal, correct? યાદ આવ્યું? 1/1 theta minimum. So a એટલે આ diameter થાય, બરાબર ને? So objective should be large or small? Large, so that resolving power is more. એટલે દૂર દૂરની ગેલેક્સીઝ માં નાનું 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 આપણે જોઈ શકીએ. મેક સેન્સ? નહીતર ઓલા લીવ્સ જેવું દેખાય. મેં તમને કાલે એક્ઝામ્પલ આપ્યું ને કે બધું એક જ દેખાય. We can't see the details. Okay, so that's enough. Now, that's it for microscopes, telescopes. How much time do we really have? 15 minutes left. Okay. So चलो एक काम करिए. હવે હું તમને
जनरल केस લીધી તો સર એમાં યુઈ કેવી રીતે આવે આ સાઈડ થી?
Sorry?
Sir, if we take general case from eyepiece, so then how UE is equal?
How UE?
Yes.
Okay, so in that case the length should be given. Only then you can solve the problem. So if you find VO from L, if you subtract VO, you will get UE. Ready?
Sir, imaginary distance from
Suppose you see the image is here at VO, and we know this length. We don't know this, suppose.
Yes.
Okay. So now if this is VO, this remaining should be UE, correct? Object distance for eyepiece, because this becomes object.
Yes.
That's what we call this. Okay. Evaluations book my input. But they don't ask anything like that in JEE. Okay. I mean, you should expect surprises sometimes. But I've seen many papers. Nothing. Not just a few years, many years. Right? Okay. So these are the things about compound microscope and all that. Now, next thing that we're going to do is मैं તમને લિસ્ટ આપ્યું છે ને શું છે હવે લગભગ ફ્રિન્જ શિફ્ટ હશે 99% એ ફ્રિન્જ શિફ્ટ છે કે બીજું કઈ છે પોલરાઇઝેશન એટલી વારમાં પૂરું થવાનું નથી
dispersion by prism.
એ તો કાલ કરાવી દીધું નહોતું કરાવ્યું ડિસ્પર્ઝન બાય પ્રિઝમ ફ્રિન્જ શિફ્ટ કરાવ્યું ચલો ના એના કરતા નોન સ્ટાન્ડર્ડ વાયડીએસી કન્ડક્ટિવિટી થિયરી થઈ જશે સમ બાકી છે ઓકે when I was analyzing things yesterday I noticed that in all the papers there is a set of 10 chapters. Right, 10 એવા ફિક્સ્ડ ચેપ્ટર્સ છે એ તમે કરી નાખો એમાંથી મિનિમમ 13 ક્વેશ્ચન્સ નીકળે આઉટ ઓફ 30 ઓન્લી 10 ચેપ્ટર ફિક્સ ગેરંટીડ આવે જ તે 13 ક્વેશ્ચન રાઈટ એન્ડ સમ ઓફ ધેમ આર વેરી ઇઝી ટુ ટેકલ લાઈક ડ્યુઅલ નેચર ઓકે એ આખું લિસ્ટ મને હવે અત્યારે યાદ નથી આઈ એક્સપ્લેન ઓલ ધેટ જસ્ટ બ્રિંગ ઇટ એન્ડ આઈ શો ઇટ યુ ઓકે તો તમને એનો ફાયદો મળશે સો what is non-standard YDAC? First of all, let's recall what is standard. You have two slits and a source here. So light will go from the source till here. There is no path difference. Yeah, okay. Sure, remember that. and then over here on the screen, suppose you think of this point P. So અહીંથી અહીંયા જાય, અહીંથી અહીંયા જાય. So we say that the path difference delta R is equal to S2P minus
S1P.
okay. આ બે કેમ નહોતા ગણતા? because they are equal, because the source is on the perpendicular bisector. So exactly opposite to that we get C. See, that is the center, zeroth fringe. એને ખરેખર zeroth fringe કહો તો સારું, right? zeroth fringe યાદ આવ્યું? So this is standard. What if it was not like this? Side માં હોય તો very simple, don't get confused. It's just that you have to take all the path difference. પાછળનો ઈ લેવો પડે. Make sense? Okay, so let's take one case. Suppose here is source, here is slit S1, here is slit S2. Let's say the distance between these is D. Right? Okay, let's say that the distance between these two is D. Now, suppose this distance is root 3. Okay, let's say this distance is root 3D. Then, what should be the intensity at a point right opposite to this source? And we have provided things like D equal to, for example, let's say 100D or something like that. Okay, our situation હોય, I have not got the numbers exact and the answer બહુ સરસ નહીં આવે, but you will get the concept, I'm sure. Okay, so if you want to find out the intensity at that point, તો કેવી રીતે કરાય? We used to do it like this. Delta R find કરતા, right? From delta R you will be able to find phi, which is equal to 2 pi by lambda into delta R, correct? Do you remember that? Okay, so when we do delta R, when we calculate delta R, we will now also have to calculate this and this. Samajh padi? That's the only thing that is different. Okay, and then we have the usual formula. Conditions yaad se, for constructive interference delta R should be equal to n lambda. Yaad hai? And phase difference should be equal to 2n. But we will talk in terms of delta. Make sense? We will talk in terms of delta R. એવી રીતે કરી અને કરી, right? But only change અહીંથી આમ લેવાનું. તો આ બેનો પાછળનો પાથ ડિફરન્સ લેવો પડે. Make sense? Okay. So suppose એવી રીતે question કરીએ where hopefully you will be able to get nice values, right? કારણ કે એમને value લખી નાખીશ તો ખબર નહીં શું આન્સર આવી જશે. So let's say this is 2D, let's say this is D, right? So can you find, suppose here is a screen that is very close. Gradually we move this screen away, right? We gradually move this screen away, right? So you have to find the first value of D. You have to find the first value of D, capital D. What is the meaning of capital D? Distance between screen and slit, right? Okay, find minimum value of D where this point P has minimum. Find minimum value of D where this point P has minimum. Understood? Minimum ક્યારે આવે? What is the condition for minimum in interference? There are two cases, two ways. One, path difference should be equal to, what should it be equal to? જો મેં તમને લિસ્ટ એક જ રીઝનથી લખાવીને આપ્યું છે કે તમે વાંચીને આવો, બરાબર? Try to recall what is the condition for minimum. Path difference equal to खाली lambda by 2. What's the most general? Delta R equal to 2n minus 1 lambda by 2. याद है ना? When n is an integer, starting with 1, not 0. बराबर? Okay, everyone recall that. અને એક phase difference ની condition. આ તો બધા માટે એપ્લિકેબલ છે હો, બોર્ડ એક્ઝામમાં આ પૂછે એટલે એવા વહેમમાં ન રહેતા કે આ આપણા માટે નથી. પે ટેન્શન ઓવર હિયર એવરીવર. આ તો એકદમ બેઝિક છે, ભલે સમ અલગ વસ્તુ છે. 5 શું આવે? What do we get? 2n minus 1 5. Can I use what 5? Barabar, this is condition for what? Minimum. That is called destructive interval. પછી maximum માટે શું આવે? Delta r equal to n lambda, right? That is 2n lambda by 2, એટલે 2 to 30, right? And what's the phase difference? 2n. Alright? તો આ બધું યાદ રાખજો. કે હવે રિવિઝન કરીને આવજો. લખો હોય તો લખી લો, પછી તમે ક્યાં મૂકી દેશો. So use this. Everyone use this and try to find it. What should be value of x? D. X. I'm that x not D. What should be the value of D here? Geometry is your friend. Draw curve diagram, path difference, lockup. Then use whatever calculations are necessary. Take wavelength of light as lambda. जरूर पड़े. Suppose you say that this is at a distance d. So અહીંથી paths draw કરવાના ને એક આમ એક ડાયરેક્ટ. Okay? So path S1P is equal to path S1P is simply equal to 2d plus d. Okay? एकदम easy હતો. What is the path S2P? Is Pythagoras theorem, right? It's going to be what? Under root 5d. પછી અહીંયા કેટલું થાય? Under root RD અને અહીંયા d. So under root d square plus d. Is it fine? પછી શું કરવાનું? The path difference should be equal to 2n minus 1 lambda by 2. So the path difference will be 2n minus 1 lambda by 2. It should give you such a value, right? It should give you such a value. So this value should definitely be of SS2p minus SS1p. So this will give you root 5d plus under root d square plus d square plus 2d. Okay, now you see, to simplify this further you need additional information. I'll be very honest. Lambda ની value lambda નાની સાથે કંઈક લિંક હોવી, otherwise you will not be able to solve it. એટલે આટલું રહી જાય, પછી આનું કંઈ ન થાય. That's not what we get typical questions. So suppose a case લઈએ where d is equal to lambda. Suppose we take a case where d is equal to lambda. Then we can simplify this further. समझाए से? Try to do it. this working. Now, often what happens is that it's confusing to find the value of n from such an equation. We just know that this should be a minimum. પણ કઈ minimum? First, second, third, fourth એવું કઈ ખબર નથી. સમજ પડી? And it's not possible to find value of n directly. So we'll go back to geometry. Suppose આ screen સાવ નજીક હોય ત્યારે પાથ ડિફરન્સ કેટલો આવે? This is under root 5 and that is 2. Do you agree with that? And we have taken d is equal to lambda. Okay, so this is the path difference when screen is right here at the slit. When જેમ આમ આગળ જશે એ the path difference વધશે કે ઓછો થશે? Think about it. Up till here it's this much. Okay, up till here it's this much, right? But screen જેવી જેવી આગળ જતી જશે, or you can think all the way from infinity also. Infinity થી આમ નજીક આવતી જાય તો શું થાય? Infinity થી નજીક આવતી જાય તો શું થાય? At infinity this path difference will become 0. સમજ પડે? કેમ આ રેઝ parallel થઈ જાય પછી પાછળ નું જાય. So gradually as it comes close the path difference is going to increase. સમજાણું? The path difference is going to increase. So what you will do is that here when we have root 5 lambda minus 2 lambda, the first case will come when this value becomes, or it goes to the next integer. Root 5 minus 2 કેટલું થાય? 0 point something થાય, correct? Okay, right? And if you would take lambda common, lambda by 2 actually આવું લખાય. તો આના પછીનો જે ઇન્ટીજર આવે ને એવી રીતે સેટ કરો, because if you are looking for the first value. Okay, so 2 root 5 minus 4 એની વેલ્યુ કેટલી થાય? 1 થી ઓછી થાય. અગ્રી કે 1 થી વધુ થાય? ડેફિનેટલી હા. ઓકે, તો પછી આને આ વેલ્યુને ઇન્ક્રીઝ કરો એટલે 1 આવે. So here you can get a 1. સમજ પડી? બરાબર? કોઈક વાર આ બે ડિસ્ટન્સીસ અલગ હોય. ફોર એક્ઝામ્પલ this is 2d and this is also 2d. તો પછી અહીંયા અલગ વેલ્યુ. So what you'll have to do is you'll have to start moving the screen away or close as you may want to do, and then decide upon a value of this bracket. So here it looks like the value should be 1. Same 1 કારણ કે આના પછીનો odd integer અહીંયા જે છે એના પછીનો odd integer શું આવે? 1. સમજ પડી? Because this is less than 1. Suppose અહીંયા 1.5 આવ્યું હોત તો પછી 3 આવે છે. Got it? Because we are looking for minimum. એટલે એવી રીતે કરીને મૂકવાનું, right? And then what's left for you is to solve this equation, right? I agree here it did take a very complicated form. બરાબર ને? આ quadratic તો છે, but it would be tough to solve it, right? Again, that's only because I was giving random numbers. Okay, if the numbers are chosen carefully, you get a simpler version. But overall, this is what the concept is, right? So next time we'll definitely solve a few more questions like this, right? Okay. અમુક એવા પૂછાયેલા છે where you don't have sources like this. આમ સ્ક્રીન સામે છે અને સ્ક્રીન અહીંયા. સમજ પડે? બધું ઊંધું થઈ ગયું. આપણે જે ડિરાઈવ કર્યું હોય એ હવે ન ચાલે. હવે એકદમ બેઝિક થી કરશો. Okay, so those kind of things are also there, right? Goodbye everyone.